All right, so we are moving on to our lesson 5 called Equations and Their Graphs from our linear equations unit here. And today we're going to be looking at a few graphs and maybe even using Desmos a little bit to look at some linear equations and identify solutions. Look at coordinates on the graphs and see how they can help us identify solutions, and as well as the meaning for the points. We're going to do this warm up in class. If you weren't in class today and want to take a look at the 5.1, which one doesn't belong, you can do that here and write down your answer. There's a number of different ways of looking at those 4 graphs and deciding which one doesn't belong. But in terms of the video today, we're going to move on to 5.2, snacks in bulk. To get snacks for a class trip, Claire went to the bulk section of the grocery store where she could buy any quantity of a product, and the prices are usually good. Claire purchased some salted almonds at $6 a pound and some dried figs at $9 per pound. She spent $75 before tax. Question 1. If she bought 2 pounds of almonds, how many pounds of figs did she buy? Okay, so let's just think about this for a second. So we've got almonds, 2 pounds of almonds, and up here it says that salted almonds cost $6 per pound. All right, so 2 pounds at $6 per pound would give us a total of $12 that she would have used to purchase almonds. So how many pounds of figs did she buy? Okay, so this was almonds. So if she bought 2 pounds of almonds and it cost her $12, now let's think about, okay, so $75 was spent total. So 75 minus the 12 that we have leaves us with $63 for figs. That's how much she must have left for figs. Now we are told that dried figs cost $9 per pound. So if she spent $63 on figs, and we know figs cost $9 per pound, how many pounds at $9 per pound would add up to $63? So to do that quickly, you could do the mental math, but let's just divide then by $9 per pound, and that leaves us with 7. 63 divided by 9 would be 7 pounds for figs. Right? Because 7 pounds times $9 per pound gets us back to that $63 plus the $12 for almond gives us that total of $75. All right, so let's do similar problem here for number 2. If she bought 1 pound of figs, how many pounds of almonds did she buy? All right, so that means that we have 1 pound of figs at $9 per pound, and that is going to therefore be $9 for figs. All right, and then again we had $75 that was spent total for Claire, so 75 minus the 9 leaves us with $66 for almonds. All right, so looking back at our almonds again, we know that almonds are $6 per pound, so how many pounds then would give us $66? You can do that math in your head or divide by $6 per pound, and we are left with 11 pounds of almonds. So that's one way to think about it. Notice when we were doing that, we were kind of reasoning through the problem, but we can actually describe this situation with an equation, and that might actually be faster for helping us solve. So number 3 says, write an equation that describes the relationship between the pounds of figs and the pounds of almonds that Claire bought and the dollar amount that she paid. Be clear be sure to specify what the variables represent. All right, so really we have two different variables here, right? We've got the pounds of almonds, all right? That's one variable, so let's call that A. And then we had our pounds of figs. That's the other thing that's changing here. That's our other variable, let's call that F. All right, and then the dollar amount that she paid, we know the dollar amount was $75 total. So now let's write the equation. So if we have $9, actually the almonds are $6 per pound. So $6 we were multiplying by however many pounds we had right up here. So in the original problem it was 2 pounds and the second problem was 11 pounds. So 6A, $6 per pound of almonds. And then we are adding to that the amount of money that we're spending on the figs, which was $9 per pound of figs, so 9F, because F stands for figs. And then we know that's going to equal our total amount of money that we spent, or that Claire spent, which was $75. So this is a little different form than what we were using in the first couple sections in the unit, or last few sections in the unit, where it was more in our slope-intercept form, y equals mx plus b, where in this one we have our variables on the same side of the equation. So standard form might be something like ax plus by equals c. It's another way of writing a linear equation, where we have the variables on the same side of the equation, which makes more sense for this problem. Okay, number 4, here's a graph that represents the quantities in this situation. Choose any point on the line, state its coordinates, and explain what it tells us. All right, so let's just choose a point. Let's choose, say, point A is a good one to start with, so point A. So notice point A is on that line, which means everything on that line is going to be a possible combination that works out to $75. So that $75 here, any point on that line should be able to work out such that the figs and the almonds works out to $75. So notice A has the coordinates 2, 7. So 2 on the x-axis, 7 on the y-axis. So point A, 2, 7, would mean 2 pounds of almonds, and on the y-axis 7 pounds of figs cost the $75 total. So that gives us a total of $75. Okay, so that would be true for point C and point B. For instance, point B, 11 pounds of almonds and 1 pound of figs would also give us that $75. Point C would be roughly, I don't know, about 6.5 pounds of almonds and 4 pounds of figs. Also gives us that $75. But what about a point that's not on the line? So here's a point that's not on the line. Point D is the point 1, 1, right here, 1 on both the x-axis and y-axis. So D is the point 1, 1. And so that does tell us something. It tells us 1 pound of almonds and 1 pound of figs does not cost $75. We know it does not cost $75 because the line represents all possible combinations of almonds and figs that cost $75, because this equation right here produces this line. We graph it. But the ones that are not on the line could tell us a combination of almonds and figs, but it would not add up to $75. We could do the calculations in our problem and figure out how much money it would cost us. In other words, 1 times 9 plus 1 times 6 would give us $15, but not $75. Same thing is going to be true over for this one over here with E. So there'd be 14 pounds of almonds and 0 pounds of figs. But again, it's not on our line, so it would not cost $75. That would be what? 14 pounds of almonds would be 6 times 14. And then 0 pounds of figs would be 0 times 9. And then that would give us that total. But again, not $75.